Today we're going to look at three different sorting algorithms in data structure and algorithm, or in short DSA. So if you taken this class before, you may encounter a lot of sorting algorithms, but the most popular sorting algorithms would be bubble sort, insertion sort, and quick sort. So, depending on the scenarios, like three of them would be like used kind of differently, but the best or the better one should be the quick sort algorithm. But I'm not gonna say like bubble sort and insertion sort is kind of bad, but they're just like really inefficient sometimes. But for like small list of array, it should be like more than enough. But you have ton and tons of data in that inside of that array. I mean, it could be like really slow. So that's why bubble sort and insertion sort, when it comes to like these algorithms, they're not super efficient at all. But yeah. Anyway, without me fussing around, we'll just go ahead and get into this. But first, before I'm gonna go to like coding like straight away, I want to show you how bubble sort and insertion sort work first. And yeah, just play the video right now. And this is how it works, okay? So basically, bubble sort, we will have a loop, okay, which go through each of the elements inside the array. Let's just say it's gonna pick like 50, and then it's gonna compare it to its neighbor number, and if it's larger, then it's gonna attempt to swap the number. So this is how it works in hindsight. So it's basically it's just gonna go through the list and then keep comparing until the array is sorted. So how do we implement it in coding? So I have a code right here already pre-made. So I have the display array and the main function right here, but we're going to code the bubble sort. Okay, so we're going to have a function to sort the array using bubble sort. Okay, so we're gonna have void bubble sort, and then we're gonna have vector. But first, let's have a boolean called, just say swap, I guess, if the array is swap or not. So I'm not gonna assign any default value to it. I'm just gonna leave it right that. And then we need to have a loop function to traverse through the array. Okay, so we're gonna have for loop int I equals to 0 and the array less than size I plus plus, and then we're going to have the swap status sets to default will have to be false. Okay, since we don't know if the array inside here is sorted or not, I'm just gonna set it to false, which means the array aren't sorted. So we're gonna set it to false. So we're gonna have another loop. This is why this bubble sorting algorithm is kind of really slow, because you have two loops. So the time complexity will be n squared, which is not good. It's just that it needs to take a lot of time. Okay, so j less than array size, but minus I and minus 1. You take away the index a little bit. Okay, we're going to check if the array j, which means this array right here, let's say 50, compared to the neighbor array, if this is larger than the neighbor array that's next to it. If it's larger, then go ahead and swap it. That's the concept, okay? So you're gonna perform a swap function that's built in the vector library. It's just attempt to swap these two numbers and set the swap status to true. And then inside the for loop, the first for loop, and if no elements swap it, and then you're just gonna break, okay? It's gonna break from this loop right here, and then we're gonna go to the um next indexed. So that's all we have to do. Let's go ahead and try to sort our algorithm right now. And this is our sorting algorithm. So I already have a vector or the array here with these numbers that aren't sorted. So just see. Okay, so this is the original array, which isn't sorted, and this is sorted array. Okay, so from 1 to 9. Anyway, let's go ahead and get to the insertion sort. So how the insertion sort work? So I do have the video right here again. It will have the white box right here, which is kind of it just like it acts like a temporary variable where it just stores a value temporarily. So it's gonna store here and then it's gonna keep comparing. So I'm gonna show the video without me just talking too much. I'm just getting ahead of myself here. I'm sorry. So let's just show the video. Oops, let's go ahead in here. So basically, first thing, it attempts to store a value into here. It's gonna have a loop to go through each index of that array, and then it's gonna store the value. And then after that, it's gonna like compare to the array that is the left of it, yeah. Or it could do it from the right side depending on how you want to sort it, like in ascending order or descending order. It's just up to you, but the concept should be the same. It's gonna store a value inside the temp variable, or we can call it more like current variable or temp, it doesn't matter. But the point is that it's gonna store a value inside here, and then it's gonna compare it to the neighbor, okay? It's gonna compare to the value that is to the left of it. And then if it sees that the left of this value is larger than the current value, it's gonna attempt to swap these two value, okay? And then it's gonna compare the value next to it as well. And if it's like larger, if the value to the left of it is larger, it's going to swap. It's gonna loop until the left is no longer larger than the current value. And the process will be repeat until the array is sorted. So that's the concept. Let's go and see it in action. So it's how you're gonna display the array. You're just gonna, insert the array right here. And then first thing I check if that array is empty, then if the array is empty, then just break out of this function. But if not, it's gonna go through the for each loop right here. So for each element inside the array, it's gonna print out the elements inside the array, okay? That's how the display array function works. I've just forgot to explain to you, but I think the concept should be like really standardized and everyone should know about this, so there's like not much of an explanation to do. So let's just go ahead and sort the array using the insertion sort, okay? Void insertion sort, and then we're going to pass in the vector. So how do we do? So we're gonna first of all we're gonna traverse the array, okay? Traverse through the array. So we're gonna have the for loop right here. So int I equals to, this time it's not gonna begin from 0, okay? We're gonna begin from 1, because it doesn't like make any sense to begin from 0, because it already select the first element as the current element, so it doesn't make any sense if you try to loop through that. But it doesn't matter if you begin from 0, it doesn't matter. So if I less than the array size and I plus plus, so we're going to set a key to the first index of that array, okay? And then we're going to have j, I mean, it up to you, you want to write it or not. So, and then we'll have this one. Again, the reason why, because I have two loops, okay? The reason why it's so slow because I have two loops. While loop is still loop, so for loop and while loop, which is time complexity is n squared, so which is not super efficient at all in the real world scenario. So allow me to explain this, okay? First of all, you traverse through the array in the first loop, okay? The first loop will begin from the first, I should say the second index. I should say second index, which is index 1, okay? The second index, okay? And then you're gonna set this key to the first element, and then you begin from j to, and then you set the array of j in the while loop right here. You want to set in here, it's fine, but the current value should be the value of the the second index. So in the while loop right here, you're just going to check if j, which is the value of the first index, which is index 0, okay? If it is smaller or larger, depending on how you use it, it's fine. So I'm gonna check it from the right side, all right? The right side. So if it's larger than key, then just go ahead and just not swap this time, we just set the address of the array of j plus 1 equals to the current array, and then the current value, okay, of the key will be set to the index that is to the right of it. So that's how it works. So let's go ahead and do the insertion sort, and let's see. Okay, same array. Let's see if it's sorted. Okay, this is the original array, and then this is the sorted array. Okay, so that's how it works. So let's go through the last array. So the last array here is going to be quick sorts. Quick sort is by far the fastest because the time complexity is only, you have only one loop to do, I think. Um, Let me show you. So this is the, sorry, okay, this is the quick sort thing, okay? So you only have one loop. It's not a loop, but I should say it is just a recursion. So basically based on whatever like number, the pivot number given, sometimes it's going to be like kind of worse. In worst case should be like n squared 2, but the average case should be n log n, which is really, really quick. This is an ideal, you know, case to use if you have a really big data set to work with, right? And then you want to sort that data set, use quick sort, it's gonna be quick. How it works. So the way it works is that, like, for example, you have an ordered array like this, right? An ordered or unsorted array like this. And then the first thing you do, you need to partition it, okay? So when you make a partition, basically you choose a pivot element. Like for example, in this case, we're gonna choose 4. So 4 as a pivot element, and you're gonna, you know, do a little bit of a partition where you move the element that are smaller than the pivot element to the left side, and the element that are larger than the pivot element to the right side. So if, for example, right here, we chose 4, so basically the elements that are smaller than 4, we're going to move it to the left side, whereas the elements that are bigger than 4, we're just going to the left side here. But still, this is unsorted, okay? And then what you want to do after this is that you're going to sort two, sort of like two batches simultaneously, right? So you sort the left side and the right side simultaneously. And then after that, it arrives to this conclusion where you've sorted this thing. It's called small, or the start, and this the large, or the highest amount, or the end pivot right here. And then you have the sorted element. So the problem is that, for example, if you you know, it really depends on the pivot element that you choose. If you're lucky, sometimes we'll choose the perfect pivot element as a median, right? And then if you chose perfect one, this algorithm works really quickly. But in this case, for example, if you have the unsorted array like this, and then you, for example, if you chose number 2, so what happened is that if number 2 is chosen as the pivot element, then you don't have the left side to sort because 2 is the smallest element in the array. So you don't have to sort the left side, so only have to sort the right side, which is still like really bad because it just falls into like n squared algorithm similar to bubble sort. You're just gonna sort like everything from the right side, and it's just not really feasible at all. Like it really depends on the pivot element. But on the other side, if for example you chose 13, which is, sorry, if you chose 19 in this case, right, is the biggest element in the array, right? If you chose 19, for instance, then it falls into the same case as 2, just sort the left side, which is really unfeasible. And if you chose like 6, if you're lucky and then chose 6, and then sure, you will have like a really good sorting algorithm right here because you're going to sort um, the left side and the right side equally. So it really, really depends on the pivot elements. The best scenario is that you want to have the left side and the right side, the number of elements from the left and right side are equal so that, you know, the algorithm will work really, really quickly. So that's the magic of it, right? So anyway, let's just go ahead and demonstrate it. So first of all, you need to have a, before we get into this, okay? So we're going to have a partition, okay? Partition array first. Or just call it partition, and you pass down the vector. And then in this case, we're going to have the start and the end. Start being the start of the array, and the end is basically the element that are end of the array. So the size of it, you know. So first of all, we're going to choose a pivot. So how do we choose a pivot? So we're going to choose the pivot based on the n, okay? So array, and then we're gonna call it n. And then after that, we're going to partition. We are going to have ni equals to start minus 1. So start minus 1 is going to be ri, and then we're going to use a loop to partition our array, okay? We don't sort it yet, okay? We're just going to move the elements that are smaller than the pivot element to the left side, and the elements are larger than the pivot element to the right side. So like I said, let's have j equal to start, and then j less than the n element and j plus plus, okay? Then what we do is that if we're just going to move the element. So we're going to have the array of j that are less than the pivot, and then just go ahead and increment this thing and then attempt to swap um the I and j together. So, and then after that, we're just going to swap the array 1 and the array n together, okay? I plus 1. I plus 1 is basically move the pivot of small elements to its position, and then you're just going to return I plus 1. Move pivot after smaller element, and it's going to return its position after that. And then this one just traverse through the array and move all the smaller elements to the left. And then we're just going to have elements that are smaller than I think, after each iteration. Elements from start to I are small after each iteration. This is what it means. So, and then I'm gonna return I plus 1. This thing should be integer, okay? Not void integer, because you return a type here. And then this partition will be used in the quicksort algorithm. So I'm gonna have void, call it like quicksort. You can call this low or high. Start should be the low one, right? And then end one should be high, right? So it depends on you, however you interpret it, it doesn't matter. So we're going to check if the start less than n or not, okay? Which basically means the left element larger than the highest element, okay? And then we're going to pivot, we're going to choose a pivot equals to partition, and then from we're going to partition the array and then start and end, and then we're going to use recursion to sort the array, okay, from I and then pivot minus 1, and then this from the low to end. So we're going to quick sort both of them simultaneously. Let's have quick sort array and then size from 0 size minus 1, which basically means you have to return. For example, if your array is size 1 to 9 is basically like 9, so the size should be the size of your the position should be 8, okay? The last one should be 8, right? So from index 0 to the last index, that's what it means. And then we're gonna display this one. So let's try it out, and there you go, it is sorted. Anyway, that's all for today's video. So we're just going to review this thing real quick. Basically the bubble sort and insertion sort is good when you have a small data set. When do you use quicksort? Basically when you have a large data set. Well, this is when you use the quicksort. But the drawback of quicksort is that if you have poorly like chosen the pivot element, this algorithm will be like slow as well, so it depends on that. But anyway, enough of me for today. So enough of today. I'll see you in the next episode, and yeah, see ya later. Bye.